Okay, so we have the first two on there for sure, but if you wanted to put this one on there and say that this is definitely not, so we just talked about why that's not, this is not a line of symmetry. Okay, so that diagonal, you're going to want to put that diagonal in, but that diagonal does not work unless it is regular. So all of the shapes you see across in example 1 are all octagons, but the first one is not regular because it's squished. So if it's kind of squished like that one is, you're not going to see that diagonal be a line of symmetry. However, this next one will have a diagonal line of symmetry. So let's draw in the original two. Okay, so we had this line of symmetry going vertical. We have this one going horizontal. We have those two. Okay, then we have the diagonals, right? It's also super common at that point right there that you look at the picture and say, that's got 8 lines of symmetry. I see how you counted that, but do you see how you double counted? That's not 8 lines. That's only 4. I have 1 here, 2, 3, and 4. So I've got 4 lines so far, but I'm not done. Do you know where the other ones are? On the points, on the corners. So every time the shape is regular, it will have lines of symmetry through the middle of the sides, like you see there, and through the corners. So this one's going to go through the corner there, through the corner there. So eventually it will have 8 lines of symmetry, but we didn't have all 8 of them drawn on yet. So here's the other. There's the other 4. So I have 4 orange ones and 4 black ones. Okay, so the other thing I want you to notice is that just because I say octagon doesn't mean that we'll have the same amount of lines of symmetry, because every shape here is an octagon. This one has 2 lines of symmetry, this one has 8 lines of symmetry, and this one has none. No lines of symmetry there. So just because it happens to be 8 sides doesn't mean it has 8 lines of symmetry. It has to be regular to have those 8 lines of symmetry. Okay? Okay, let's go on to the next little part here. How many lines of symmetry? Okay, so take a second, take 60 seconds, and draw some lines of symmetry and see how many you get for each shape. It's okay if you don't find them all. Just see how many you can find for each shape. We've got 6 shapes. Okay, what about Mr. Butterfly? How many lines of symmetry? Just one. Just one. If you cut him in half this way, he's definitely not the same on the top and the bottom. It's kind of like you as a person. You have arms on the top, but you don't have arms on the bottom. So we're going to cut him right in half here. Okay. What about the letter H? How many lines? 2. There are 2 lines of symmetry for the H. There's one there and one there. Okay. What about our snowflake? So 3. Okay, so when you say 3, did you do your 3 this way? Like through the middle of the prongs? I don't know what you call that on a snowflake. Okay, so that's 3. That's 3 orange lines. But can I go in between them as well? Yeah, I can go in between. And then in between here. And then in between here. So there's actually 6 on that one. And it's because if you were to draw a hexagon kind of like around the outside of that snowflake, it would be a regular hexagon. That's why it's got 6. The same thing for this, I'm going to guess orange, or maybe a grapefruit or something, like this part right here. There's 1, 2, 3, 4, 5, 6, 7, 8 slices. So what we can do is we can go through the slices, or we can go in between the slices. So we can go 1, 2, 3, 4 if we go in between, but we can also go through them. So we can go 1, 2, 3, 4. So that one has 8 as well. Okay. Our lovely lobster only has 1. Okay, now what I said was if the shape is regular, which in all technicality this is regular, what do you call those, tentacles of the starfish? I don't know what you call them. The legs of the starfish are all the same, or approximately the same. So this would be a regular pentagon. But when you have a shape like a pentagon, or if it has 7 sides, or if it was a nonagon, you can't go through the middle of each side and through the vertices because there's not an even number of them. So for this one, there's going to be 1 that goes through every leg, and then in between. So there would be 5. Did I draw them all? No, missed one. Sorry. Okay, so there's your quick lesson on line symmetry. So most of the time, you would just look at, especially in elementary or middle school, you just look at, is it symmetric on both sides, and you say yes. Okay, this time we're kicking it up a notch because you have to say, does it have line symmetry, does it have rotational symmetry, and where are those lines, and what is the degree of rotation? So let's cover that last part, which is rotational symmetry. Okay, so a figure has rotational symmetry if it can be mapped onto itself by a rotation. So if I rotate it and it looks the same, but the rotation has to be 180 degrees or less. Okay, we don't consider it to have rotational symmetry if you rotate it 360 degrees and you get back to what the shape was originally. Okay. So this down here just gives you an idea of different angle measures, so what those would look like, but we're just going to practice this for time's sake. So let's flip this over to the other side, and let's practice. Okay, so we're going to practice some easy ones, and then we'll get to some that are a little bit more challenging. It looks like the same pictures we had before. Okay, I'm going to leave mine exactly as it is. Okay, you look there. What I want you to do is to take your paper and turn it 90 degrees. Doesn't matter which direction. Turn it 90 degrees. So turn your paper at 90 degrees. Does your picture look like my picture exactly? No, because yours is long, right? So does it have 90-degree rotational symmetry? No. Okay, flip it 180 degrees. Does yours look like mine? Yes. So this, it says, does it have rotational symmetry? Yes, this one does. And how many degrees did it take to get there? 180 degrees. So it's 180 degrees or less. So this is an example of 180-degree rotational symmetry. Every parallelogram is also an example of 180-degree rotational symmetry. This one also has reflectional symmetry. It also has line symmetry, but a parallelogram would not. So that's an example of something that would have that rotational symmetry but not have line symmetry. What about this guy right here? Turn your paper 90. Does it look the same? Yes. Yeah? That one's only 90. All right, if you turned your paper 90 degrees, would you see the same picture for this third triangle? No. What about if you flipped it upside down? Would it look the same? No. And if that's all you go, because you can check 270, but it's not going to work either. So this one does not have rotational symmetry. So it has no rotational symmetry. Now, there is an easier way to find this degree measure, because what if it's not 90 or 180? How are you going to tell the degrees? Okay? Well, you look at the shape, and the shape kind of has 4 pieces that are the same. So it's got 4 of these points, right? Okay? So those 4 points that are the same, if you take 360 and you divide it by 4, what do you get? 90. That's how we're going to find this number, especially if it's not super easy like 90 or 180. Same thing here. How many points are the same here? Is this point the same as this one? Are these two the same? No, but this one is the same as this one, right? Same degree measure, same look. So if you take 360 and you divide it by 2 pieces that are the same, you get 180. Now you might be asking, why did you pick these 2? I didn't have to pick those 2. I could have picked these 2. Just how many parts are the same? Okay, let's go down to the bottom here. Now when I say how many parts are the same, you can only count that if you say it has rotational symmetry. Does this have 2 parts that are the same? I mean, it's got a wing and a wing, but this doesn't have rotational symmetry. So don't say it's 180 degrees. This does not have rotational symmetry, so we're not even going to check. What about the H? 180. Is it the same as if you turn this sideways? Does that still look like an H? No. No. Looks like an I. Okay? So it's got 2 parts that are the same. It's got a top and it's got a bottom. That's why it's 180. So this one is yes, 180 degrees. Do you know this one? How many parts are the same? How many you got? 1, 2, 3, 4, 5, 6. There are 6 similar branches in this shape. So what's going to happen is when I rotate it, I only have to rotate it to here before it looks the same. So how many degrees is that? Well, if I take 360 and divide it into 6 even rotations, how many degrees would be in each one? 60. 360 divided by 6 is 60. Okay, what about down here on this orange? How many slices do we have? 8 slices. There are 8 parts that are the same, which all that means is I only have to rotate this wedge to here before it'll look the same. That's all the farther I have to go. There are 8 of those turns in 360. What's 360 divided by 8? 45. 45 degrees. There we go. Okay. The lobster has 2 pinchers that are the same. Nope. You only look at how many parts are the same if it actually has rotational symmetry. This has none. We know this does not have any rotational symmetry. How many legs does Mr. Starfish have? 1, 2, 3, 4, 5. What's 360 divided by 5? 72. Thank you. 72 degrees. So from here to here, that's what we're talking about. That would be 72 degrees. I would only have to turn it 72 degrees before it would be right back on top of itself. Okay. So that's how you find it if it's not super nice. 90, 180, 270. Okay. Okay. If it's equilateral, there's just a couple of questions down here. This is an equilateral triangle. Equilateral triangles have lots of symmetry inside of them. So they have how many lines of symmetry? Well, remember we talked about you can go through the center to the vertice because it's an odd number of sides. So we're going to go through the vertex and then the center of the side. So we're going to have 1, 2, 3 lines of symmetry. So it's not this one and it's not this one. Okay? And then here's kind of a trick question. How many degrees is the rotational symmetry? It's a kind of a trick question because you know that an equilateral triangle has 60 degrees, right? So you say 60. How many points are the same here? We've got 1, 2, 3 similar vertices. What is 360 divided by 3? You've got to turn your paper to get this vertex all the way over to that vertex. How many degrees would that be? 60? Nope. That would be 120. This is kind of a trick question. It's a good question, but it's kind of tricky to your brain because you think 60 degrees is an equilateral triangle. Okay. I'm going to pass out the homework tonight. If you have not finished homework from last night, you have 5 minutes.